Okay, now we're in section 5.5, and this section is on joint probability and contingency tables. So when we want events, we can place them in what's called a contingency table. We've got one down here, and so we'll start with an example, and that's pretty much probably the best way to do this. So it says, as part of a pick your prize promotion, a store invited customers to choose which of 3 prizes they'd like to win. The responses could be placed in the following contingency table. So what they did was they recorded the person's gender, and then they recorded their prize preference. So there was 3 prizes that they could prefer: MP3 player, a camera, or a bike. And what they did was they just counted. So this is kind of just like a frequency. They counted how many men said they wanted MP3s, and there was 117. How many men wanted cameras? There were 50. How many men wanted bikes? There were 60. And then over here it shows the total for the men, which is 227. So we're adding left to right to get to this total here. Then we look at, so then they found women to be 130 MP3s, 91 cameras, and 30 bike. And again, if you add left to right those numbers, you get 251 total women were surveyed. Now, if we look at the columns going from top to bottom, if we look at MP3 player, well, we can break it out into, okay, well, 117 men and 130 women wanted MP3 players, so the total number of people who want MP3 players is 247. So these numbers down on the bottom are the addition of the columns going top to bottom. Now, those totals that I just talked about, so this bottom row and this rightmost column, they form, and we've talked about this before, they form the margins of the table. And if we do probabilities based on these numbers, so if we end up dividing into these numbers, we're going to call that a marginal probability. So let's look at an example. If we say, what's the probability that the person surveyed was a woman? Well, we would look at the total women, which is 251 over here in this marginal total column, divided by the grand total, 478. So there was 478 people surveyed. And again, as we saw in class, you can get to this number either by adding down in this last column or adding left to right in this bottom row. And if you divide those two numbers, you just get 0.525. And again, if we convert that to a percentage, that means about 52.5% of the people surveyed were women. Now it gets a little more interesting because in a contingency table you can have all sorts of probabilities that crop up. So if we have any probability that's not based on these totals over here, or I should say both numbers aren't in the totals, in the margins, then we call it a joint probability. So the joint probabilities are gonna have numerators that live in this area here. In the slide here, it looks a little lighter blue than the other background blue. So in this box here, any number we pick from there and divide it into one of these numbers over in the margins, we'll call it a joint probability. And this is going to be the case where we have an and statement. So we're looking for the condition of the probability of women and camera. So what this would mean in a little clearer English is, what's the probability that we surveyed someone who turned out to be a woman and she said she wanted a camera as her prize? Well, these two things tell us where in the contingency table to look. So it says look in the women row, and then this camera says look in the camera column. So if you were to draw 2 lines here, one through camera and one through women, those 2 lines would intersect right here at 91. So we know that we want to look at 91 of the people fit this condition out of how many total people? 478. So about 19% of the people surveyed were women who said they wanted a camera. And that'll do it for 5.5.